This should not be a very hard day for you. This is your intro and your exit to area. Like we are spending one day and one day only on area. You will spend, so essentially we're doing, today is the only day we're spending in unit 1, then we go straight into surface area with fractional edges. Just kidding. You go straight into retrace volume. Sorry. We go into spending a little bit more time with area and fractions. Then by Friday of this week, we're doing fractional edges with volume. And then Monday, we are testing again on unit 1. So we are spending one day on area today, we are spending one day on surface area tomorrow, and 2 days on volume. And then after that, we start, we're going into unit 2, which essentially we're gonna spend, and this is where it gets a little bit weird with the way that they have the pacing guide for this class. We're gonna go back, spend a few days on finding area of shapes on coordinate grid, finding and decomposing, rearranging shapes for area, and then we go into 7th grade material scale drawings. So if you don't understand area, you don't understand fractional edges, you don't understand volume or surface area, you are going to struggle hugely with scale drawings. Alright, so if you thought the pace was a tad bit fast now, it's about to really pick up this week and next week. So just preparing you guys for what's going on. And we should be done with unit 2 by, essentially we'll be done with unit 2 in 3 weeks. Because we have like 20 days and 20 days and then like 10 days and like 12 days. This curriculum is interesting.
Isn't this like the first year of this?
And if they take any teacher feedback, I will provide all the feedback that I feel. Because, like, I get wanting to push you guys and all of that, but like at the end of the year, you're still taking the 6th grade EOG. So if I fly through expressions and equations, which they give me 15 days to teach the entire 6th grade curriculum, expressions and equations, when 6th grade gets 35 days to teach it, like they cut it in half.
Yeah.
So I have to, like, the hardest thing that I have to teach you guys all year is 15 days. And then at the end of the year, I teach you 7th grade expressions and equations, but it's like, it doesn't make sense to me because you're still being tested on the 6th grade stuff.
Yeah.
And I guess they think, well, if you can do the 6th grade, or the 7th grade stuff, you can do the 6th grade stuff, but then it's like,
You didn't
no,
learn it.
because it's completely different.
Yeah, you didn't
Like
learn
it is, like even like scale drawing, what we're going into is completely different from what we talked about. It's just, I could talk about it all day, but it's definitely a learning year, and I hope that they listen to the teachers and the students and the parents. You know, I hope that you guys, I mean, it's fun, don't get me wrong, I do enjoy teaching it, I enjoy the pace of it, because there's also days where I'm like, okay, we've been doing parallelograms in my regular classes for a week and a half now. I'm like, if I see another parallelogram, I'm vomit. I mean, it's just like, you can only spend so much time on parallelograms, and I get like the process and the thoughts on like building from one to the other, but it's like, enough is enough. So we gotta find a happy medium for everybody. So, yes.
I have a question about math class. So is it like only your 3rd period or all periods?
That's only you guys. So, there will be some shifting and moving though, because there are some kids that are sitting in 1st or 2nd period that, essentially said, no, we don't wanna go into because of the size of the class, which would have started us at 38 and 39. But there are some students sitting in this room that won't be in the class much longer either, because they're not pulling the weight, they're not doing the work, they're not taking it serious. So we're gonna be shifting some kids in, we're gonna be shifting some kids out. I mean, we don't wanna wait too much longer, because like Alexa came from Miss Gibson's team, and So she missed all of unit 4 that we did. She's not gonna get unit 4, cause we've already taught unit 4. So like she missed all of the fraction, all the decimal review, but she's already done half of the geometry review. So I mean, it'll be a benefit for her for the fast pace of what we're doing for the rest of this unit. But she's not getting any of unit 4 fractions and decimals. And that's the other thing that we're like super upset about, cause it doesn't align. Like, if you move from this class to go there, from there to come here, like you've essentially missed half of the unit either way you go. So there's a lot of thought that needs to go in, a lot of changes that need to happen. Okay, so let's go ahead and get our folders out. You will need 1 or 2 colors, depending on how colorful you actually want to be. But you have to have at least 1. If you want to have more than 1, that's fine, but I am not going to give you a ton of time to spend on this. Alright. You need to title this Area Flip-Up Formulas.
Wait, what was us?
I'm just writing on, well, obviously where you can flip the pages up. And then right underneath that in your color, someone please raise your hand and tell me what the word area actually means. And if you need to move closer, you can definitely move closer, so that you can see this. So what does the word area mean? Jeremiah, what do you think?
Like how like the perimeter is like outside, I think like area means like the inside of something.
Yes, so it is the inside of a 2D shape. And please make sure that you add 2D shape, because it's not a 3D shape, and we'll talk about surface area and volume, and we'll talk about that a little bit later.
Volume is 3D.
Volume is 3D, and so is surface area. Alright? So it's important for us to understand that area is the inside of a 2D shape. Also, because I have been a Slack teacher, you will notice that for the first period and second period, they're really good about annotating our essential questions. We're still on area analysis. I apologize. But we will start doing this with our essential questions moving forward. Okay? You just might have to remind me. Alright, now, underneath, you should have 1, 2, 3, 4, 5. 1, 2, 3, 4. You should have 5 flaps. And on the first flap, I need you to put square / rectangle. Yep, so see how like you have this one? So the very first one that like you can, has a lip, I guess, I don't know how to say it. But, so square goes here, parallelogram goes there, trapezoid there, triangle, and irregular shape. Alexa, if there's anything that you want to add that we add that you don't have, that's fine. If not, you can, like I said, just follow it. Raise your hand. Alright, thumbs up when you have these labeled so that we can move on. Once you have that labeled, flip up the first flap. So this first one that is your title, flip that up for me, please. Oh, okay. Alright. So you do need to be refreshed and reminded what perimeter is. So someone please raise your hand and tell me what perimeter is. If you were listening at all today, you were already told by one of your classmates. Ace.
It's the outside of a 2D shape.
Yes. Alright, so when you're finding the area of square or rectangle, you can use the same formula for both. So, some students like to say length times width, and some students like to do base times height. I am not going to be crazy about what you say, because essentially they both mean the same thing when we're talking about squares and rectangles. So it's either B times H or L times W. Alright, so our first example that we're going to do is this shape. Please raise your hand and tell me if this is a square or a rectangle, and how do you know? Jack,
It is a square
how do you know?
because the length and width, all sides are equal, and it has two lateral sides, or parallel sides.
Okay, so then what formula do you want to use?
A equals 4.
No, what, like, do you want to use base and height or length and width?
Well, I use length times width.
Okay, so we're gonna do A equals length times width. So what is our length? Raise your hand and tell me what the length is and what the width is. Layla. Okay, so it's 4 inches times 4 inches. So the area of this square is, raise your hand and tell me please. Gabriel.
16 inches squared.
Perfect. Why am I excited that you said inches squared?
Because otherwise, if you don't say squared, it most likely would be perimeter, or it could just be length.
Right. So, and it's very important, and you will get things marked wrong if you do not put the unit squared. That is part of area. When we talk about volume, if you do not put the unit cubed, it will be marked wrong. Like, it is very important that you show me that you realize this means one set of unit times another set of unit equals a unit squared. You are multiplying two numbers. When we do volume, we do cubed because we multiply 3 numbers. All right, here is your next shape. So the last time we did length times width, so let's do base times height. All right, raise your hand and tell me what is my base, what is my height? What's my base? Caroline?
Your base is 6 and your height is 2.
All right, so then what is the area for my rectangle? Raise your hand, tell me. Alexa?
12 inches squared.
12 inches squared. And if you want to make a box around that and this one so that you can see, even better. All right, stand up when you have this copied down. All right, go ahead, flip up the next flap if you haven't done so already. And now we are going to be talking about parallelograms. Oh, I need to give you a disclaimer, I can't draw, so if you judge me, I'm going to throw a pen at you. Not really going to throw anything at you, but I really cannot draw, so please don't judge me. All right, so when talking about the area of a parallelogram, the formula that we use is base times height. This one you have to use the base, you have to use the height. That's actually very important. So your formula will look like A equals B times H, or A equals BH. Everybody understands what this means, correct?
Yes.
Yes.
Raise your hand if you do not.
Oh, sorry.
Okay, just making sure. Alright, so your parallelogram looks essentially like a stretched out square or rectangle. Alright, it is important though, that you notice that the top and the bottom are your bases. Or if you shift it this way, this must be a flat straight. They cannot be diagonal. You cannot do anything with your diagonals. Okay? When you are finding the base and the height, you do not use the diagonal. So again, like we're gonna identify this is our base. So then you can have a dotted line that has a little square in the corner. Raise your hand and tell me what that means. Christian?
So a line means that instead of being slanted, it will be straight, and the represents 90 degrees.
Okay, so yes, the dotted line means it's straight, which is important because our height has to be straight. When it is corresponding to the base. But this 90-degree angle tells us what type of lines did we just make. What type of intersecting lines did we just form? Alexa? Yes. So this base and this height is perpendicular because of that 90-degree angle. So take your color and make it stand out a little bit that you just formed a perpendicular line right here. And you will never use the slants when you're finding the height. And again, this dotted line simply means height. Alright, so please also put that down that you do not, put that in capital letters, use the diagonal / slanted line for the height. You do not, you do not, you do not. If you listen to nothing else the rest of the day, please listen to that. Alright, so your question is, if the height equals 3 and the base equals 7, what is the area? So this is for a parallelogram. What's the formula that we're going to use? Excuse me? Mason? So A equals base times height. So Mason, give me the numbers that I'm going to be throwing in there.
7 and 8.
I'm sorry, what'd you say?
3 and
3 and 7, yes. So 3 inches times 7 inches is gonna give me what, Mason?
21. You said
21 what?
inches cubed.
How many numbers did you multiply?
Huh?
How many numbers did you multiply? How many? It's late, I get it. I'll help you out.
21 inches.
Yes. So the answer to this should be 21 inches squared. Again, stand up when you have this written down for me so I know I can move on. About 10 more seconds and then we're going to move on with this one. Alright, go ahead and flip up your foldable, and now we're looking at the trapezoid. So, the formula for a trapezoid is interesting. If you understand the trapezoid, the formula is amazing. If you do not understand the formula, decomposing and rearranging it to a rectangle is your best bet. Okay, I'm going to show you the formula today. I'm not going to talk about decomposing and rearranging. Alright, so the formula for the area of a trapezoid is going to be base 1 plus base 2 divided by 2 times the height. Which seems super intense, a little bit crazy, but it is really not that difficult. If you write it out just using letters and numbers, this is what it looks like. So B1 plus B2 divided by 2, that does not look like a 2, sorry, divided by 2 times your height. But you're about to find out how unconfusing it is. Alright, on a trapezoid, you have 2 bases. It does not matter which base you identify as base 1 or base 2 as long as it is the top and the bottom. So base 1, base 2. Then your height is identified by the dash or dotted line, whatever you want to call it. So you essentially are taking the number that is on top plus the number that is on bottom, dividing it by 2 and multiplying it by your height. Again, it is not that difficult. We're about to do an example and you're about to see what it looks like.
I get it now.
It sounds more intense than it really is.
Yeah. It is intense.
Bless you. All right, so who would like to try to add the numbers into where they go in our formula? So we're looking at our trapezoid, and we're trying to take the numbers and put them in the correct location. All right, Cooper, what do you think?
So you need to say the equation.
You can just tell me whatever you feel comfortable with.
Okay, so it would be 10 plus 16, because those are your bases. And then over 2, so divided by 2, which would be 13.
I'm not doing all that. We're just building the formula for the moment.
Oh, okay. And then times 6.
Okay. Does everybody see where the 10 and the 16 and the 6 came from? Is there anybody who is confused? Please raise your hand. This is speak now or forever hold your peace kind of thing. Because like this is the only day we spend it on this and we're going to keep it moving. So if you get it, good to go. If you don't get it, you need to raise your hand now. Okay. All right, so as Cooper was saying, you do 10 plus 16, you get 26 divided by 2 times 6, which when you do 26 divided by 2, you get 13 times 6, which gives you what, Cooper?
13 times 6. 78
Just 78
feet squared.
feet squared. So that is your answer for your trapezoid.
It's a big process, but whenever you get it down, it's really easy.
Right. It just seems more intense because you got base 1 plus base 2
It's
divided by
like,
this.
Wasn't it like, isn't it like, distance? I don't know, it's like calculating speed.
Oh, like
Oh,
distance
yeah.
times
Yeah.
4 divided by half or, yeah. no.
it's that.
Yeah. All right, stand up when you have this copied down for me, please. If we're talking, that means I'm giving you too much time. All right, have a seat. Triangle. Now, the formula for the area of a triangle should be ingrained in your brains by now, but if not, it's base times height divided by 2. You can write it a couple different ways. A equals BH divided by 2, or you can do A equals half the base times the height. If you do not get part of your foldable down while we're in class today, it is going to be posted on Canvas, so you can just simply copy it down while you're doing your independent work. There are 2 types of triangles that you're going, well, there's lots of different types of triangles that you're going to encounter, but the ones that you kind of need to know the difference between. Will look similar to this, will not be exact, but the height is the main thing that you need to understand and where it is identified. All right. So, the first example that we're going to do I think so too. All right, A equals. What 2 numbers go in here? What 2 numbers go in there? Caroline.
It's 3 on the first and then 5 on the
Okay, so we have 3 times 5 divided by 2. What is 3 times 5? 15. We're going to divide that by 2. And then what is the area of this triangle? Caleb?
It'd be 7.5 inches, centimeters squared.
Yes. And I don't know if I told you guys, but I despise fractions, so anytime I don't have to use one, I will not. Fractions are my nemesis.
I like decimals.
I totally prefer decimals every way, shape.
Yeah, I would say that decimals are painful.
Alright, so that is one type of triangle that you may see. The next type is going to look similar to this. And we're going to do, so the first one we just did the base times the height divided by 2. So this one I want to do half the base times the height and see how it works out. All right, so what 2 numbers do we plug into our formula? Christian?
8 and 4.
All right, so when I do A equals half, what is 8 times 4? 32. All right, and then what is half of 32? 16 feet squared. All right, a little note to remember. Units for area are always square. Bless you. This means inches squared, centimeters squared, feet squared, miles squared, meters squared, kilometers squared, anything squared. So you get like the gist of it?
Yep.
All right, when you have this done, please stand up. How are you gluing that down, babe? No one told you to glue it down. Because it's about to get real hard to do the next part. That's why I haven't had anybody glue it down yet. Alright, so I know there are still a few people finishing up, but I'm going to ask a question. What is the formula to find the area of an irregular shape? Raise your hand and tell me. What is the formula to find the area of an irregular shape? Raise your hand. Raise your hand. You can't cheat. Not on this one. I'll ask again. What is the formula to find the area of an irregular shape? Y'all are supposed to be smart. Like, so smart kids, right?
Oh, yeah.
What is it? What is it?
Circle.
What?
Does that include circle?
No. We don't do circles in sixth grade. All right, I'm testing your intelligent brains right now. Take a minute and think. Think. There's a formula, I promise. I promise. I didn't ask how you do it. I said what is the formula. Ace, please do not stand on the chair. All right, Mason, what's the formula?
Length and height.
No, there is no formula. It's all the formulas together.
I knew it. I'm like,
Oh. There is no formula.
So do we just write there is no formula?
No, we're about to write a whole bunch. So, you'll notice this last one is the biggest one for a reason. Okay? Alright, so you need to write, not like teeny, but if you write big, you need to really concentrate on trying to write a little bit smaller. So there are 3 steps that we have to write, and then there is a problem that we have to solve. Alright, so step 1. You're going to chop, or a math word I like to use, decompose the figure into pieces you can solve. So this is where the multiple formulas come in. You guys, it could be triangles, it could be squares, it could be rectangles, it could be trapezoid. I mean, just depends on what the irregular shape is. Step 2. You are going to find the area of each new shape. And then step number 3, you add up all the areas to find the total area of the figure.
It's over. Oh.
How many of you guys enjoy doing surface area? How many of you guys have been exposed to surface area? Surface area?
What is surface area?
I was taught.
I don't even know what surface area is.
Okay, that's fine.
Oh.
So, and the reason I ask is because surface area is going to be very similar to irregular shapes. So, this is one, sorry, that you are going to want to keep in mind. How to chop it up and find the areas and add them together.
Oh, yes, I know we did this.
I haven't done it, so I think I might.
Yeah. So this is.
All right, thumbs up when you have this copy down.
So, we're solving it now.
What?
Yeah, we're using this to solve it.
We're going to solve that, yes, in a second. All right. Gonna add some measurements to our shape. So, what is our very first step when we are trying to find essentially a shape that you can't just use a formula for? What do we need to do, Jackson?
We need to chop them up into shapes.
Okay, so I'm going to chop this shape like this. And there's a reason I did that. Why do you think I chopped it with two long rectangles and then possibly a square or another rectangle? Why do you think that? Why do you think that? Hunter.
So it keeps even and easier to like do area with.
Okay, so you said even. So essentially, can we assume that this shape and this shape are the same?
Yes.
Yes.
Raise your hand and tell me why. If I'm looking at this shape, what are the characteristics of a rectangle? Like, what do we know about a rectangle? Ace?
Two of the sides are longer than the other two.
Obviously, yes, that is true. All right, Brock?
So there's two pairs of the same like size line, I guess, and
Mhm.
so they'll each have the same amount of feet.
Two pairs
Yes.
of words.
So essentially, opposite sides are the same. So if I know that this side is 20 and that side is 20, then I gotta know that this side is 20 and this side is 20. So then if this side is 30 and that side is 30, what do I know about this side and this side?
30.
They're all 30. Which means that's less math I have to do because these two are the exact same shape. So we're gonna number, this is gonna be number 1, this is gonna be number 2, and this is gonna be number 3. So for shapes number 1 and 2, we're going to use the formula for a rectangle. So base times height, length times width, whatever you would like to use. And we are going to do 30 times 20. Raise your hand and tell me what is the area for number 1 and number 2. River? Just 600? There's no unit.
Oh yeah,
Feet. Squared. There we go. All right, so each one of these are 600 feet squared, 600 feet squared. So I'm gonna simply multiply this by 2 already, just so I know. That's one less thing I have to do later. Alright, now, for shape number 3, this one gets a little bit difficult because technically we only have one number. And we cannot assume, based off of the information that was given to us on the shape, we cannot assume that anything else is 30 or 20 or anything like that. So for shape number 3, what do we have to do first? What do we have to do? What do you think we have to do first for shape number 3? Jack?
Figure out the unknown length.
Okay, how do you
Or,
think?
yeah.
How do you think we can figure that out? I forgot a number, sorry. My bad. With that being 12 feet. I was like, what's going on here? So this side right here, from the 20 feet to the 32 feet is 12 feet. That is my fault. All right, Cooper, what do we need to do?
Well, now that we know that's 12 feet, we need 30 feet minus 12 feet. Because the total is 30, not part square.
Yes. All right.
We get 18.
So what is that 18 now representing? The what?
The height
This figure down here?
of the third.
Yes. So now we know that our height right here is 18 feet. Now, am I ready to find the area of this rectangle? All right.
It's a square.
It's not a square.
No, it's not.
It's not a square because it's 32 by 18. If it's a square, both sides are the same, right?
Yeah.
All right. So 32 times 18. Raise your hand. Tell me what that equals. No, any other of those you could cheat, not this one. Actually, no, go ahead. Give me the answer.
576.
Not just 576
Feet squared.
Feet squared.
feet squared. So I've got my answer, right?
No.
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 No, 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 no.
All right, raise your hand and tell me, what do I have to do last? What do you think, Charles?
You have to add up all the areas.
Yes. So you have to take your 600, your 576, and your 600 and add them up. However, we already did a little bit of our work, so we're just going to add the 576 feet squared. Stand up when you have your answer. If you are standing, your mouth is closed. Adam, what'd you come up with?
I came up with 1,776.
What are you missing?
Oh, feet squared.
Yes. All right, so that is the process for finding the area of an irregular shape. All right, go ahead, take this and glue this down on your area foldable page. Do not talk. Jack, may I borrow your iPad, please? Can you log into Canvas for me before you give it to me? Alright, so you are gluing this down right here on your page. Then we are sliding over to the right side that says area and perimeter task cards. Yes, please. Alright, everyone stop gluing and writing and whatever else you're doing. Alright, get out your iPads. We are going to walk through how you get to the next part of your assignment. Okay, so go to my Canvas page and get here and do not go any further. Oops. All right, thumbs up when you're here. You're not going anywhere else. You are on this home screen. So if I see you anywhere else, I'm going to take your iPad from you. Because I have entirely too many students who are like, I don't know where to go, but yet I'm about to show you, and then we don't know where to go. All right, once you get here, yes, you have this beautiful playlist that you can look at. I do not want you to go there. All right, you need to start getting used to, yes, look at that home screen, but your life needs to live in modules. Okay, so when you click on modules, this will come up. You need to go to first 9 weeks, week 4, September 19th to the 23rd. You will notice Monday was yesterday. That's where our test information was. So click on Tuesday for today. So we did the area foldable. That's what we just did. Now, this is going to be the activity that we're going to do here in a minute. It says area and perimeter task cards. This is different than what it normally is. So like this link just pulls you into Google and it's just a picture. Okay? Oh, crap. There we go. So when you go to a link that has this little down arrow right here, in math especially, if you click on that, it should bring it up right in Canvas. It will not take you to Google Drive. It will not take you anywhere. And it should, I don't know why it's not, but there are opportunities, and we'll be doing this as we're reviewing for stuff this year, but you will be able to write on your screen and it will save. All right, this will come in handy when we go over, when we review for certain unit tests where we're annotating and all of that. But here are your area and perimeter questions. So yes, if you're looking at the first one, you're like, Miss Kinney, are you serious? Like, really? But as you scroll down to some of the much later ones,
Be a little bit harder.
just a little bit. All right? Please, 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 ladies and gentlemen, we are still struggling with reading questions carefully. All right? Do not assume every one of these is about area. It says area and perimeter for a reason. You might have to find perimeter to find area in these questions. All right? Adam, what are you doing, babe? So if you are good to go, you may get started. You're doing your work on the page that is to the right of your foldable. All right, I'm about to walk around, hand you your cool down for today. Please complete your cool down. It should take you all of about 28 seconds. And put it in the blue third period bin.
So do you pull down first?
Yes, start this. Once you get the cool down, finish that quickly and then put it over there. Label it as, why are we having conversations?
I was trying to get into my Canvas because I had to go.
Okay, well, go to modules. And then go to Tuesday. Click on Tuesday. And then it should go to area and perimeter. Good. Yep. Essentially, yes. So you went and had any homework after you finished your quiz yesterday. There were too many people who didn't finish, but I couldn't not. You can disconnect your iPad if you want.
What place?
Oh, see bad things popping up on there.